Are you an S4 student, a VACist, or even then, an all-level teacher? Welcome to this episode, Digital Science for You. I'm Nicholas Norbert. Digital Science and Virtual Lab. You could ask yourself, what is that all about? Well, Digital Science and Virtual Lab is a student learning easily and a teacher teaching with no hassle. Digital Science and Virtual Lab software is a whole all-level science and mathematics curriculum presented in a digitized format. A mixture of 2D, 3D, video animation with text and sound. How it works, all you need is a computer with software and you, the student, and we are ready to roll. This should be an interesting episode of an interesting subject. A subject disliked by many. Why? Well, maybe because it's misunderstood or it's taught in a complex manner. Mathematics. Imagine graphs in colors, tables, lines in bold, an eloquent, interesting teacher. Coming up is an interesting lesson about graphs using digital science and virtual lab.
Hello, how are you doing? Welcome to Mathematics Today. I'm very happy to have you watching us. I'm Nicholas Masajage. I'm going to teach you mathematics. Yes? When you're in your classes in schools, you find that there are people who come into the classes every day and they come to give the numbers. Number of girls in class, there are 5, there are 6, there are 10, there are 20, there are 80. And each of the classes, they have to go there and pick the numbers. Sometimes your class captains do it. Sometimes other people do it in the classes. They get all this enrollment data. And all this data has to be analyzed to find out how many girls we have in school, how many boys do you have in school, what's the mean number of people in school, all that. That is very hard to do if you're doing it manually. Let me show you. For instance, if I come to your classes today and I come getting the data, and I know in S1 I have 80, S2 I have 90, this one I have 80, another one I have 60, another one I have 70. So I write all the way up to the end, up to a class where I have 100 children. All this is data collected from the classes. All that data has to be analyzed. So if I'm using a paper to analyze this data, I'll have to cancel, go through the errors, all that boundary. Now, for us to learn better, we use statistics. Statistics enables us to summarize that data into a single unit, and then we're able to analyze it very well. This is a topic that begins being taught in S2, but for today, I'm going to go at purposes of data display, which is taught in S3. And I'm going to use a system that enables us to analyze it better and digitally. It's called Digital Science and a Cyber School. So if I can move to S3 here, under Digital Science, I come and see Mathematics. Under Mathematics, I come to Statistics. Then under Statistics, I come to Data Display. I show the data. This is what I have. Now, data is anything you collect. Leave alone the data you get, MBs, that's data that you get on your phones. Now you're looking at data that's actually useful data that we get, mathematical data. So any data that you can collect from the environment. When people came to your homes for census a few years back, they were getting data. How many have a TV? How many have salt in their homes? All that is data. Now, to analyze that data, they go back and sit down and they use statistics, which you are learning now. And you will be the same person in future doing exactly what they were doing in your homes. Right? Now, there are many ways of presenting this data. You can analyze it and get the median, get the mode, get the mean of the data, all that information, which you have from prior information in Senior 2. Now, for us, we want to look at two methods, which are actually practical and optical. You can actually see them. That's the ogive and the histogram. To start us off, we shall start with the histogram and the frequency polygon. This here, if you see these two diagrams that are on our table today, this here is a curve, a simple curve, and the other one there is a polygon, yes, a closed polygon. Now, if you continue to the next 2 out of 3, we are going to be able to see a histogram. A histogram is simply a representation of data in bars that are connected. Leave alone the bar graph that you have in geography. I know now you're doing bar graphs in geography. This is mathematics. In mathematics, the bars are all connected to form a histogram. If they're not connected, they can't be a histogram. That's why our data has to be very well analyzed. Look at the example below. We're going to construct a histogram for the following data. Now, if I was not using digital science and I had to write this data down, I'll have to redraw this table on the board here. All this table, all this data, all these frequencies on this table. But that takes a lot of time. So to summarize, to take a shorter time and us to learn better, we'll go ahead and use a simple digital science. So when you look at this, this is our data here. This is our data that we have there. Now this data, when you come down here and write it in the frequency distribution table, you find that you have to get first of all, the 2-class limit. This is data which must be made continuous. That's why we say there should be no spaces between the bars. It must be continuous. You get the number of men is our frequency now. So you write the number of men is still in a frequency distribution table. Now, if you look at digital science, while in your classrooms, if I'm to draw the same histogram, I'll have to first draw lines. Lines. Then I go ahead and draw. Here I put for you the frequency. Then here I put for you the class boundaries. In this case, we're having weight, so I name it as weight using the class boundaries. Then I have to come and begin plotting, looking for the values, maybe 2 here, 4 there, 6, 8. This takes a longer time and it's very hectic. Very hectic. Digital science eases our lives by making sure that we can get this information easily drawn here, where you can see it very well. And as well as if I'm using this, I'll still draw with the same lines, and I have to draw the same lines, and the work will not be as interesting as it is when you look at it in color, with multiple color. For each bar, you're seeing a color. So when we cut it down to the 2-class limits and make it continuous, 40.5, 45.5, we keep on moving along the class limits. We do not use the classes because the data must be continuous. We use the class limits. The class limits are used down here, but when we're naming, we name it as the weight. Please, that's a common mistake that you're using now. Do not make the mistake of naming it as class limits or class boundaries. Down there, name it as the unit, the quantity we are measuring, which is weight in kilograms. So we put their weight and then we draw our bars. The color makes it come out much better. Does it look beautiful to you? I think so. Let's go to the next example and we see. So, for instance, if you're getting data in a hospital, say you become a doctor in future. Yes, some of you want to become doctors and you get data about people who are diabetic. Yes, these are patients. In a study diabetic patients in a village, the following data was observed. Those between the ages of 10 to 20, there are 2 like that. This is the number of patients. This is the age in years for those for the groups. When you analyze this data, if you are to get the data very well, you have to go ahead and draw a histogram, which is something like this. Yes, then you are able to get the mode of the data. What is the mode? You can get it using this histogram. By looking at the bars even, you can estimate where the mode is. But we're going to see how we get the mode later on. Let's go to the next example. When the frequencies of the classes are plotted against the midpoints of the corresponding values, we get what we call a frequency polygon. If the data shows, this data shows the number of patients treated in a hospital per day. Next, we're going to get a frequency polygon. First of all, let's step in constructing a frequency polygon. While for the histogram, we have to draw the bars, like we're seeing here. I have to draw the bars for the histogram. For the frequency polygon, we shall simply plot the values along the middle. You see that? The first step, you draw the histogram for the data. After doing the histogram for the data, join the midpoints of the bars in the histogram. And you keep on joining them to the adjacent bars, the middle of those bars on top. After you join them, you formulate what we call a frequency polygon. Now, a frequency polygon is different from an ogive. When they ask for an ogive, draw an ogive. They ask for a frequency polygon, draw a frequency polygon. These are all going to be observed right here under digital science. Let's go on back. We're going to go to the third slide here. This is an exercise. You can try it out. If you have access to this system, this is an exercise which shows you how to draw the data. So you can test yourself by drawing the data down. So you go ahead and try the data out. Then you can check if you are right. If I show you the answers here, I'm going to see that I have the histogram drawn out very well in color and the frequency polygon as well. Plus the table with the class limits and the heights and the frequency. The labeling is clear there, the height and the number of plants. Yes? Plus the frequency polygon coming out very well in the lines that are showing in the middle of the bars. Yes? Do you see that? Does it look beautiful to you?
You're You're still watching Digital Science for You. Hope you're learning a thing or two about this lesson. You can also access the programs and the sessions via our main offices in Lugogo via the Uma Showground. You can follow us on Facebook and Twitter, CSTSUG. We'll be right back right after this.